All of you welcome. In our next period, we see the next article, Dirichlet problem for a circle in the xy plane, which is called as Poisson integral formula. Poisson integral formula. Let the circle C be given by mod of xi equal to r, where xi is given by x plus iy. The problem is to find the solution u of xy such that del 2 of u equal to uxx plus uyy. Del 2 of u means this is the second order derivative, del square by del x square, like this, where u equal to f of theta on C, where theta is angular coordinate on C, that is xi equal to r e to the power I theta on C. In figure, w and r square by w bar are inverse point with respect to the circle mod of z equal to r. This is point w and r square by w bar are the inverse points. Now the w bar is the complex conjugate of the point w. Let f of xi be analytic function in the region enclosed by C such that the real part of f of theta on mod of xi equal to r is f of theta. The real part is f of theta. The inverse point of w is r square by w bar with respect to circle C, and r square by w bar lies outside C, and w bar is the complex conjugate of w. By Cauchy integral formula, we have f of w equal to 1 upon twice pi I integration along the circle C f of z divided by xi minus w dz. Here f of z divided by xi minus r square by w bar is analytic inside and on the circle C. By Cauchy's theorem, we have 1 upon twice pi I integration along C f of z divided by xi minus r square by w bar dz equal to 0. Now taking the difference of 4 and 5, 4 minus 5, equation 4 minus 5. Now this f of w minus 0 equal to right hand side minus this side left hand side, we have this. Now taking the LCM of the this xi minus omega into xi minus r square by w bar, cross multiplying, here we have xi minus r square by w bar minus xi plus w. Xi minus xi get cancelled, therefore we have w bar minus r square. We take w bar, here LCM, therefore w bar minus r square divided by w bar. Again here xi w bar minus r square and w bar cancels in the numerator denominator. Therefore 1 upon twice pi integration along C. We simplify this, multiply by xi, multiply by minus omega, we get this. Then we take minus n common here, minus of xi into r square per w bar minus w bar xi square minus w r square, and we shift the minus sign in the numerator. Therefore w bar minus r square get changed to r square minus w into w bar. But xi lies on the circle C and w inside C. So we set xi equal to r e to the power I theta and w equal to r e to the power I phi. R is less than r. Therefore put the value f of r e to the power I phi equal to 1 upon twice pi I. F of r e to the power I phi, we put here xi equal to r e to the power I theta, r square minus r square into d theta divided by this, r square plus r square minus twice r cos of theta minus phi, implies f of xi equal to f of r e to the power I phi equal to u of r theta r phi plus I v of r phi. This is the real part, this is imaginary part, equal to 1 upon twice pi integration 0 twice pi u of r theta plus I v of r theta into r square minus r square d theta divided by this term as it is. Now I will replace this f of r e to the power I theta f of r e to the power I theta by this, u of r theta plus iv of r theta. Now we compare or equate the real parts on both sides. Here in the left hand side, the real part is given by this u of r phi. On the right hand side, the real part is given by this u of r of theta into r square minus r square d theta divided by denominator. Equating the real parts on both sides of the equation. In the left hand side, we have u of r phi equal to, on the right hand side, integration 0 to twice phi u of r phi u of r theta into r square minus r square into d theta divided by this term as it is, r square plus r square minus twice r cos of theta minus phi. Now, but we have written here the real part is denoted by f of theta. We have written in the theory. Therefore, we put the real part by f of theta, but real part equal to f of theta implies u of xy equal to u of r phi equal to, we take this r square minus r square divided by twice pi I, here 1 upon twice pi I into integration 0 to twice pi f of theta d theta divided by r square plus r square minus twice r cos of theta minus phi, which is called as Poisson integral formula, which is the required solution of the Dirichlet problem. This is called as the Poisson integral formula. It is the required solution of the Dirichlet problem. Which is the required solution of the given Dirichlet problem.